A few thanks I'll start out with. Representative Pfluger. First, his thanks for serving our country as a fighter pilot. His thanks for going into politics to serve our country as a representative and a passionate guy about energy. He has been a champion and passionate about energy for a long time. I'd also like to thank all of you. Everybody in this room is here for a reason. Like you're believing in an energy source that's been around for a long time and hasn't achieved liftoff yet, but you believe it should achieve liftoff. And of course it should and it can. But stuff only happens when passionate people put their efforts, their hearts and their treasure and lean into something to make it happen. But I look across this room and I see people that are going to make geothermal happen. And in fact, you're making thermal happening already in this room. We're just going to take it up a few notches and make geothermal happen. I also want to thank President Trump. Look, here's an East Coast guy, a real estate developer and a businessman on the East Coast who's all in and passionate about energy. He instinctually gets that energy is what makes everything else happen. I always say when people tell me energy is this sector of the economy, I say energy is not a sector of the economy. It's the sector of the economy that enables everything else. If you get energy wrong, nothing else matters. If you don't have energy, none of your other sectors matter. You have to get energy right. And the degree you get energy right, oh yeah, we have energy, but it's expensive and it's becoming more expensive and it's less reliable. You can go the way of Germany or the United Kingdom, who were birthplaces of the Industrial Revolution and industrial powerhouses that have adopted different energy policies. They've rapidly raised their price of energy. They've made the reliability of it uncertain, and they've made the outlook look even dimmer than it is today. And what happens in that setting? Germany has more than doubled the capacity of its electric grid, but produces 20% less electricity today than it did 15 years ago. Of course, at a 3 times higher price. So it makes the citizens of that country poorer. It makes energy-intensive manufacturing just leave because you can't compete if you've got high, expensive energy. That's just President Trump got elected seeing the United States drifting that same way. Over the last 4 years, the previous administration, demand for electricity barely grew in the U.S. It grew maybe 2% cumulatively over 4 years, yet average electricity prices across our country rose well over 20%. The demand for a commodity is not growing. The cost of the main sources that produce our electricity in raw material form are declining. How does your electricity price go up over 20%? That makes it harder for people to pay their bills. It makes it not a very welcoming place to invest new money and investment into our country. And we have a new industry arriving, artificial intelligence. I know you've talked a lot about it today, so I won't say too much, except to say this is going to have huge demand growth. And if we don't meet that demand growth, guess what? It's going to go like a lot of other energy-intensive industries out of our country, somewhere else. We don't want AI somewhere else, not just because we want the jobs and investment here, but AI is going to drive scientific progress and national security. We can't afford to lose this industry. We need it here. And the only way to get it here is to implement President Trump's agenda of affordable, reliable, abundant, secure energy, which everyone in this room we got to add more legs to that stool. Let me talk about geothermal real quick and in my very nerdy fashion. I worked in geothermal for the first time well over 30 years ago. We called it hot, dry rock then. Drilling wells deep underground into very hot rock, oil and wells just like oil and gas wells, but they were vertical wells, right? So in a vertical well, we had 1 injector well and 2 producer wells. This was not traditional geothermal where the waters are fluid saturated. It was dry rocks, very hot. Inject underground, flow fluid through the injector well, produce it up 2 offset wells. We could produce very hot water and steam and produce electricity or heat or energy in the form you wanted it. But the problem was not very much. Too expensive. We demonstrated the concept, but it wasn't economically viable. Why? Because in traditional geothermal, we have a fluid, water, that's heat, and we move that heat up by convection. We're taking a fluid that's carrying heat and it's moving. Next generation geothermal, we don't have fluids or permeability in most of our rocks underground, but everywhere we go deep, it's hot. And the fluid flow of the heat flow through rocks is slow, because then it's conduction. The heat conductivity of rock is low. The heat capacity is high. There's a lot of heat there. It does not move quickly. So the way you make geothermal work is massively more contact area. We have to touch a lot of rock, put a lot of cheap underground plumbing, mostly in the form of hydraulic fractures, which are very cheap because they're made out of water and we inject them from the surface and create this fracture network. It is, as I'm sure has been discussed, entirely parallel with the shale revolution. We produced oil and gas from reservoirs that have permeability, just like traditional geothermal. Even though most of U.S. and global oil and gas is trapped in the source rocks where it was formed, if you drill a vertical well into those resources, you don't get much out. Maybe your fracture goes 1,000 feet long. That's a lot of water. That's a lot of pressure. Maybe that zone of accumulation's 50 feet thick. That's 50,000 square feet of contact area. Not even close to enough to make shale work. Shale only worked with a different frac technology and different drilling technology where you could get millions or tens of millions of square feet of contact area. Because the flow of oil and gas through pores that are very small and very low permeability is the same thing. It's just like conduction of heat through rock is very slow. Migration of fluids through impermeable rocks is very slow. So the answer is not 50,000 square feet of contact area, it's millions or tens of millions of square feet of contact area. But I think as you've seen in the shale revolution, that was like a neat, exciting thing in the late 90s. I think we wrote out the frack that changed everything paper almost over 20 years ago. But it's now, then it scaled up, right? Industry and innovators scaled this up. I'm looking at one of them right there in the audience. Made this happen at scale and made our country from the largest importer of natural gas on the planet to the largest exporter of natural gas in the planet in less than 15 years, while also going from 1,500 rigs drilling for natural gas to 100 rigs drilling for natural gas. 1,500 to 100 and production grows massively. Net importer becomes net exporter. Maybe way more important for American people is natural gas became wildly cheaper. That's allowed some reshoring of manufacturing here. That's allowed a growth of American electricity production, where natural gas has grown market share. But next generation, and I think you're all here for that same reason, that same shale technology, it's tailor-made for geothermal. Large contact area, large cheap water-based underground plumbing, and we can mine simply massive amounts of heat from underground that we can use to produce electricity, we can use to produce district heating or process heating right at the surface, and done right can even help produce cooling. So this is just an awesome resource that's under our feet. And last thing I'll say is that term, that word resource. People tell me, oh, these countries have lots of natural resources. I think that's a misnomer. There's natural materials that are underground or natural conditions that are underground. It's very hot underground. It was very hot underground a long time ago too, and that wasn't of value to anyone. That's just a condition or a material. It only becomes a resource when technology and people and action turn it into a resource. So that geothermal condition that's been under our country for a long, long time, I see in this room and in entrepreneurs across our country. We've got to put money to work. We've got to put capital to work. I want to be a service provider and help the government get out of the way, make it easier to get regulatory approvals, easier to do innovations, easier to take that next step. But that condition is underground. Let's work together and make it a resource, a large resource, to better energize our country, improve the quality of life for everyone in our country, and help enable AI, manufacturing, reshoring, and stop the rise of our electricity prices. Let's bring abundance. Let's bring more energy for better lives and lower prices. And I'll stop there. Thank you so much for being here. Thanks for all you do.